So in problem 3, we have a cylindrical wire that has a radius, and we're looking for the current through the outer portion of the wire between two values. So let's say that the area of that wire that we're going to look at is going to be pi r squared, which is the area of the entire cylinder, minus pi r over 2 squared, which is the region that we're looking for. So this is pi r squared minus pi r squared over 4, or 3 pi r squared over 4. And now we can plug in the value of the radius. I'm told it's 2 millimeters. So 0.002 meters squared over 4, which gives us about 9.424 times 10 to the negative 6 meters squared. And we know that the current is the current density times the area. So plugging in what we know that the current density is 2.0 times 10 to the 5th amp per meter squared, and the area we just found is 9.424 times 10 to the negative 6 meters squared, which gives us 1.9 amp. Part B says find the current if now the current density is changed to a variable that depends on the distance. And so we can say that the current density along a wire length would have a element area dA. And so if we take the dot product between those two, we get J dA cosine theta. And if we take the current density and the area element to be in the same position, that direction I mean, then we can say this is J dA if J and dA are parallel, so they point in the same direction. Right. So now this J times dA is nothing more than an element of current, so the current itself is going to be the integral of J dA in this case. And we're told, again, we're going from R over 2 to R, so some initial condition to some final condition. And we're told that J is AR squared, and the differential element of area for a cylinder would be the circumference 2 pi r times a small thickness dr. Notice we have some constants in 2 pi and a, so we can take 2 pi a outside, and then we have r cubed dr from r over 2 to r. And so we can do that. This is 2 pi times a. If we integrate r cubed, we get r to the 4th over 4 between r over 2 and r. And we can simplify this by saying this is pi a over 2 times r to the 4th minus r to the 4th over 16, which is the same as pi a over 2 times 15 r to the 4th over 16. And we can rewrite this as 15 pi a over 32 times r to the 4th. And now we have all of these values, so we can plug them in. 15 over 32 pi is a constant. A is 3.0 times 10 to the 11th amp per meters to the 4th times the radius, which is 0.002 meters to the 4th, which gives us about a 7.1 amps.